Something we learn about in the early elementary years, um, quite often in the elementary classroom, is the difference between an even and an odd number. And these can be explained in a variety of ways. It's pretty important to be able to count by evens, but it's also very nice to be able to count by odds. And I'm sure a lot of you have practiced with this. Evens is more common for the average person. So I'm going to clarify that this is base 10, but just our normal numeration system. If we were to count in evens, you probably know the sound of it. It sounds something like this: 2, 4, 6, 8, 10, 12, and so on. So even numbers end in what we call an even digit: 2, 4, 6, 8, or 0. Well, another way to describe even numbers is that they come in pairs. So you can think of like shoes in the closet, for example. If you look in your closet and you have 10 individual shoes, you would know that's 5 pairs of shoes. But if you have an odd number, that would not be a pair. So they don't pair up. Okay, so that's a way to think about odds, is they are not paired. All right, so the odd numbers sound something like this: 1, 3, 5, 7, 9, 11, 13, and so on, always ending in the odd digits, which are 1, 3, 5, 7, 9. Now that seems pretty straightforward, but that's just base 10. It's not quite as obvious in other bases. And the reason I wanted to illustrate this is because it may seem obvious to you as a student, or even as an educator, if you want to be an educator, that counting in evens and odds kind of feels natural and normal, most of the time in evens, but it will not feel that way for kids. So to illustrate that, I want to talk about what would even numbers look like in a different base. So the reason we're doing that is because if I put you in a base you're not familiar with, you realize that it's not so straightforward to recognize what an even number is just by looking. So here's an example. If I were to put you in base 3, okay, in base 3, and I give you a number, 1, 1, base 3. And I would just simply to ask you, is it even or odd? Well, instinctively, you might think, well, ends in 1, so maybe it's odd, or I don't know, or maybe base 3, who knows? And so there's a couple ways of deciding that. One way is to figure out what its base 10 value is. And another way is to just go back and remember the counting sequence in base 3 that we looked at in the last video. So in the last video, we counted in base 3, 1, 2, 1, 0, 1, 1, 1, 2, and so on. If you look at that, it is the 4th counting number. So that means that 1, 1 in base 3 is this many. Well, if you see it visually, you can see that this many pairs up nicely, right? It is an even number. So that would be even. It's quite difficult to decide. If you extend this counting sequence out, though, you might be able to notice a pattern. So let's do a few more numbers in the counting sequence: 2, 0, 2, 1, 2, 2, 1, 0, 0, 1, 0, 1, 1, 0, 2, 1, 1, 0. That may be enough. Let's stop there and see if we can notice something. So the evens will start at 2 and then skip, count from there, just like in base 10. 2, 1, 1, 2, 0, 2, 2, 1, 0, 1, 1, 1, 0. Now, if you look at those, they can end in 0, they can end in 1, they can end in 2. Doesn't really give you any good clues, does it? It's much harder to recognize an even or an odd number in base 3, because just by looking at it, I can't really determine. And you may be wondering, is there a way even to tell? So I'm going to leave that as an exercise for you to think about. You can send me a message on that if you'd like. It's not an assignment, but there actually is a way to tell whether it's an even or an odd. And each base will have its own unique characteristics. So base 4 might be a little easier to recognize. So let's take a look at the counting in base 4. 1, 2, 3, 1, 0, 1, 1, 1, 2, 1, 3, 2, 0, 2, 1, 2, 2, 2, 3, 3, 0. That ought to be enough. Let's take a look at the even numbers. Again, starting at 2 and skipping every other. 2, 1, 0, 1, 2, 2, 0, 2, 2, 3, 0. You may quickly recognize that in this case, the evens in base 4 either end in 2 or 0, and the odds end in 1 and 3. So it feels a lot like base 10. But each base will have its own uniqueness to it and is something to be discovered. That being said, I just want to point out that when we talk about evens and odds to the kiddos, it's not going to be obvious to them at first. And it's a great opportunity to let them explore their noticing, that they can notice that evens they behave in certain ways and odds behave in certain ways. And the way that we really notice whether they're one or the other is to look at the ones place digit.